Hi everybody, welcome to the breadboard. Today we have a video on another industrial PLC, but before you turn off and say not another industrial PLC, this one has something a little different to offer. First of all, it is based on open source hardware, namely the Arduino Leonardo and the Arduino MEGA2560. Secondly, it's all wrapped up in a completely ready-to-go industrial package. So it's DIN rail mountable, it is all 24 volt compatible, you can get relay outputs, 0 to 10 volt analog inputs, and a whole bunch of other options. And all the relay outputs, of course, are isolated and can drive up to 240 volts at a few amps and things like that. And where these are from is a company called Boot and Work out of Barcelona in Spain, and the product line is called Industrial Shield. And RS Components from the UK has sent me these for review and to play with and to share with you how easy or not, yet to be determined, they are to use. Now the nice thing about these things is that, as I said, they're based on Arduinos, and you can program them using the same Arduino IDEs that you're used to when you're just playing with an Arduino and a breadboard or some other electronics. So they've done nothing to close you into a particular PLC programming language. For instance, the previous review that I did with the Bath Electronics had a Micon programming IDE, which, what you had and what you could use is exactly what came within that application, no more, no less. And that's fine if that's what you need for basic industrial control and everything. The benefit that these PLCs have is that they're not closed in. Now there's a downside to that. It makes it a little more complex to program because you're going to be using C, you're going to be pulling libraries together and things like that. But on the plus side, you have a lot more flexibility. For instance, in my case, I've been looking for a controller to go with my CNC project that I'm starting. And one of the things I wanted to be able to do was send commands to something via USB or something like that, but then have it interface to a number of different control elements for the CNC, like limit switches, power control, as well as driving the actual motor control interfaces as well. And with these industrial shields, you have all of those options. You can even drive a CNC spindle using Modbus and various other things. All of these options are there, and all you have to do is pull the libraries together. Now I have two shields available to me. One is based on the Arduino Leonardo, which is basically very, very similar to the Arduino Uno. So it has 32K of flash space for programming and things like that, and all the usual Arduino Uno kind of interfacing, but it has additional hardware which gives it relay outputs, 24 volt compatibility and everything else. And we're going to have a look at that shortly and get into more details of the specifications. The other industrial shield that I have had sent to me is based, as I said, on the Arduino MEGA2560. So of course it's got 256 K of program space, a lot more RAM, and a heck of a lot more I/O on it. The module I've got only uses one expansion board, but you can actually get modules that go up to far more expansions, and what it does is it kind of concertinas the modules next to each other, all extending out from the 2560, and we'll go and have a look at that in a moment as well, so you can see what I mean. As I said, these all come all wrapped up nicely in a professional DIN mount enclosure, all very quick release connections for the front where you can actually pull them out, leave the wiring intact, so that if you ever did have a module go bad on you, it would be very easy to switch it out. They have a combination of 24 volt inputs and outputs, as well as relay outputs, and they also have a number of the pins from the MEGA2560 or from the ATmega328 microcontroller on the smaller controller board. And these can actually communicate with each other via I2C, RS232, Modbus, RS485, etc., etc. In order for these to communicate with each other, of course, if you're using I2C between them, you need to have pull-ups on the I2C bus. So Boot and Work, when they sent me the two controllers, they also sent me the pull-up modules that can click onto a DIN rail so that the I2C bus is handled properly and things. So that's great. We'll have a look at that as well. So anyway, I thought I'd start this video out, aside from the intro that I've just been doing, a little differently. And instead of doing a tear down, we're going to do a build up. I've actually already pulled the units apart because I know a lot of you are thinking, yeah, it's open source, it's Unos or Leonardos and Mega 2560s, but it's probably not the ones that you get right off the shelf. And what I wanted to show you right off the bat, that actually it is. So if I just pull these up right now, this is the Arduino Mega 2560 that I've pulled out of the larger of the two units, which is the Arduino PLC 21, which has 21 I/O, and it's all based on this Arduino Mega 2560. All right, and as I say, I've only got one extension module on it, but you can buy these with more extension models and more I/O and everything. This particular one also comes with an Ethernet port on it too, so that you can hook it up to remote devices and talk via, well, basically any software that you happen to load up on the Arduino Mega to communicate with external devices. That could be via Modbus, TCP, it could be running a website for remote control or whatever you wanted to do with it. It's just limited to your imagination and the libraries that you can download and load up on here. And then for the smaller unit, which is the this one does not, this is the one that has the relay output. It's got 1, 2, 3, 4, 5, 6, 8 actual. So this one, which is the Arduino Leonardo, this is pulled right out of the smaller unit, which is a Ardbox PLC 20 with I/O relay outputs. And this actually has 8 relay outputs on the board, which are all isolated from each other, which allows you to do mains control and various other things, as well as having I2C and other interfaces at the logic level being available on the external connectors. But again, you can see this is a genuine Arduino board that they're using in here. Now when we start looking at the hardware itself in just a moment, you'll see that they've actually gone to great lengths to industrialize, for want of a better word, the Arduinos into an infrastructure that is tolerant of 24 volts, that can drive mains and everything else, and have gone to great lengths to make sure that they're isolated and protected where necessary for an installation into pretty much any industrial control situation that you would like. And they have many examples on their own website where this is already done, and they've even started a community there where different users that have created solutions based on this these industrial shields have shared their solutions so that other people can use it as well. And it's very much like the Arduino forums, where it's all based on using the Arduino IDE with the different libraries that you can download and everything else. So that's all very well and good. And what I want to show you now is, let's go look at the hardware, and then we'll build it back up again so that we can actually power it up and have a play with it. But because of the nature of this, it's not just a case of firing up the GUI configuration tool that allows you to drag in pre-confined bricks onto a graphics display and say, okay, there, we've done. I just did that a few days ago with the Bath STG 600 mini PLC controller, and you know with that one, if you'll see it on my channel, you just drag blocks onto a screen and configure it. In this case, as I said, the downside of having this so open is that you have to get to grips with pseudo C programming and things like that, very much like an Arduino IDE. But the nice thing is, of course, there is a huge following for the Arduino range, and so there's plenty of help if you need it to get your applications up and running. What these industrial shields do is provide all of the hardware interfacing to make that side of the job far, far simpler. You don't have to build all the interface logic and things. You can just buy them ready built and just add your application to it, which is excellent. So let's go look at the hardware. So first off, we'll look at the Ardbox PLC 20 IO's relay board, which I have spread out in front of you. It's the front row, these ones here. And as you can see, there's basically 4 parts to this. You've got the main part of the enclosure, which has printed labels for all the different relay outputs and logic, the 24-volt IOs and things like that. And it's two-sided for the IOs as well, so you've got a lot more logic, more relays on one side. Sorry. You have the IO is on both sides of the DIN mountable enclosure. So on the side we're looking at right now, we've got all of the transmit and receive, the I2C, the SPI bus, etc., and a few relay outputs. And of course we have the 24-volt DC input. And on the other side of the unit we've got more relay outputs, some more IO pins, and a few more relay outputs. This is all marked up on here. This is all CE approved, by the way, so good for use in Canada and various other places. Next up we have the actual Leonardo, which we were looking at before. This is a standard off-the-shelf Leonardo official Arduino board. Next up we have the power module. Now this power module is actually the same, or it looks to be exactly the same for the 2560 as well as the Arduino Leonardo based board. So it's obviously you can see here it's a switch mode power supply. You've got two main controllers, some big inductors here, nicely fused with a ceramic fuse, and no expense spared with the capacitors. These are all Nikon capacitors, which are all good quality ones, and they are, can I see the temperature rating on these? 50 volt, 680 microfarad. It doesn't say the temperature rating on them, but I'd imagine that being an industrial PLC, there will probably be the 100 odd degrees C rated caps there to give you the extra life and reliability that you would need. And then the last board here is the actual I/O board. So the Arduino Leonardo plugs onto these headers here, right here, and then the power supply board plugs on this higher riser and connects via these pins here to the lower board. And there's some pins here for the 24 volts, and then you've got the DC voltages coming back down here to the main board. The Arduino, when it plugs in here, of course you've got the SPI bus connecting in, you've got all the standard IO pins and everything else. And then what you have on the board, on the base of the board basically, is all of the relays to control the outputs. And these relays are Omron relays, so they're good quality relays. And I'm just trying to see what rating they are. 5 volt DC control and 5 amps at 240 volt output. So that's all you know that you would need, and it looks like there may be some OPTO isolators for some of the inputs on here as well. But you can see the board is very well laid out. It's got unpluggable and plug-inable connectors, so right here, so you can just, trying to remember the right way these go. Losing bits. I guess you just pull them out. Alright, so they just pull right out of the board. So you can have these all wired up to your cable harnesses, and if you needed to switch out the board for some reason, you can just pull it out rather than trying to unwire everything. All of the relay outputs, though, they're not on one big bus. They're actually individually connected, and they have screw terminals on them rather than the quick release ones, and that would be more beneficial, especially if you're having mains kind of voltages coming in here as opposed to lower voltage ones, because you really want to make sure that they're secure and not going to vibrate loose or come out or anything like that during operation. So I think putting the screws on these connectors was a wise choice. And then the other side of the board, of course, you've got more input outputs and everything else. These are 3 relays. You've got 2 relays here. You've got 3 relays here, which makes 8 in total, and this bottom one here is actually the 24 volt inbound supply, and all it does is go straight in onto this small connector here, rises up to the power supply where you've got the fuse and everything else, of course. On the top of the board you've got a whole host of LED indicators to tell you the state of what's going on. You have a small amount of configuration dip switches, which we'll go into in a little bit, and you've got a reset push button just in case you need to use it. Now, one of the things I'll just quickly touch on right now before we move on is that because you've got relay output and I/O and everything else, and this is actually an Arduino based open source hardware, then it's important to make sure that the physical I/O that you're using matches what you're programming the Arduino Leonardo to be. So if you've programmed an output on an I2C bus or SPI bus or even logic outputs, you really don't want to have the equivalent relay clicking on and off as you're sending data out or something like that. So you need to make sure that you follow the instructions, and we'll have a look at those in the second video to go with this. Right now we're just reviewing the hardware and everything else and looking at this. You need to follow the instructions carefully to make sure you configure it properly, because you could do some damage to either your connected infrastructure or to these controllers if you get it wrong. Now, there are plenty of instructions both on the website and that comes with it to help you out with that. And as you can see, these are very well made. They're all it's all clicked together enclosure for these, so that I was able to open them up quite easily so that I could show you. And in a moment we'll go through and we'll start reassembling it. But for now I just wanted to show you what all the hardware was inside these. And from what I can see, I don't see any bodge wires or anything else, and these all look to be very well made and very well put together. So I'm actually quite happy with that. Let me see if I can lift this one off to see if we can actually see what's on the other side of it, because I haven't done that yet. So let's just pull that out there, and you can see, well, not one single bodge wire on the back, and no patching and no additional circuitry on the back of that too. Very neatly laid out. Plenty of ground plane for the high current parts of the circuit, i.e. the power supply, ground, and things like that, being made available to other parts of the circuitry. Yeah, it all looks like it's been put together very, very nicely. So that's very neat, very well done. And obviously most of these signals do not require high current, and where they are, the relays are very close to the outputs, as you can see here. So this bank of 6 relays down here, for instance, if we flip that over, you can see that the relays are all up close to the connectors and everything else, and there's a definite delineation between the control circuitry out here. The flood planes for the ground and everything have stopped short, and now you've got the contacts here, the 2, 2, and 2, for the relay that is well out of the way of the main logical side of the board, which is nice to see. And even though the creepage clearances and things that are needed for these boards is probably only measured by 1 or 2 millimeters, you can see that there's actually plenty of clearance here for these boards, all right, between the relays and the logic control. So that's quite nice to see. And then the relays that are up the top here, here's 2 of them on this side. There is a little bit more logic. I'm just looking at how these are connected here. One relay is in the north-south orientation, which is this one here. So the control logic's down here, and there's still plenty of clearance between even these wires and the actual relay contacts. And then the last one, which is here, is sitting up here. And again, there's plenty of clearance around the contacts and the control logic side, which is actually a little bit into the board here. But this is low voltage, and this is the high voltage side. And you can see a faint trace. I don't know if you can see it on the camera, but there's a bit of a faint trace here going out to the pins for the connector. So again, they've made sure that there's plenty of clearance between all the high voltage sides of this and the low voltage control logic, which is where you may be connecting to human machine interfaces and stuff like that. So that's all good to see. All the logic side, of course, which is the low voltage, either 24 volt or lower control signals, don't have any such clearances, and nor do they need it, because it's only 24 volts or less. It's only on the relay contacts where you're going to have the high power and high voltage connections where they've actually added the extra clearance all the way around. So that's good, and happy with that, and I think you would be too. So let's just put that back on the case, and we will move on to the next board. Now these do take a little bit of messing around with to get the components apart. I mean, you certainly wouldn't want them coming apart when you're building and assembling this. So one of the reasons why I tear these down is so that you don't have to. You can see what's inside, you can get assurances of how well these are made, and so you don't have to actually do it yourself. Anyway, so that's this one done. Now let's go look at the AT MEGA2560 based PLC, which is the Arduino PLC 21 iOS that I have here. So let's start with the controller again, which is obviously the AT MEGA2560. This is an absolute bog standard official Arduino MEGA2560. So if you ever had to get another one because you for whatever reason you locked up or you programmed it badly or anything else, you can just replace this with one that you can buy yourself quite easily, which is really nice. As I said, the power module is exactly the same as the previous one that we looked for the smaller board. And now there are two controller interfaces with this one. Let me just move up a little bit. You've got this is the 2560 is actually sandwiched between two boards. So the first one we'll look at is this one, which is actually an extension of the ATmega's basic logic functionality. So what we have here is an absolute standard, by the look of it, ENC 28J60 Ethernet controller, which is a very standard Ethernet controller that is available on the open market for the Arduino series. And so they've just dropped an absolute open source one that they picked up from somewhere, dropped on here, and they've just used the ribbon cable to bring it into the I/O for the 2560, which means that, again, if you ever had any problems with this, you can easily get a replacement, drop it in. It looks like it's actually glued in with hot melt glue just to hold it in place, which is actually fine. So what else we have on here is you've got your power LEDs, you've got a reset button, you've got an auto reset switch, you've got your, when the Arduino is plugged onto here, you've got your USB connection, you have your Ethernet connection, and then you've got some configuration jumpers here, which I mentioned before. There are some more for the other I/O board as well. This one is actually just for controlling the ones on this board. And then what we have on this side is, you can see here that there are three connectors. And remember before I said that this one is the 21 I/O, and what you can do is you can actually get variants of this module with more I/O. And the one, when we go through this, you'll see that the one I have here, which is over here right now, has a wiring loom which plugs into this first connection, and you can actually get two more of these modules that would then plug into the additional connections, giving you more expansion. I don't know if they're available on their own so that you can expand them, but you can certainly buy them with the modules in there, and so you can get more I/O into the one unit. Now, there's nothing to stop these things from talking to each other via the I2C or the SPI bus and things like that as well. So don't think that just because you haven't got all the I/O in here, you're stuck with that. You can either buy another complete programmable module, or you can get maybe the expansion modules just to add to this on its own. So what have we got? We've done the case. Okay, we've got the I/O, the second module here now, which is part of the expansion for this. And I haven't unplugged it right now, but you've got this wiring loom which goes through the enclosures and actually ends up plugging onto the main control board here to allow it the I/O from the MEGA2560 to be brought out to this board. And what you can see here is we've got the a whole bunch of the transmit and receive lines. So you've got the RXO, the I2C bus, and SPI bus, all being brought out here on this side. And then on the other side, we have just trying to find where the markings are for that one. On here. So here on this side we have standard I/O capabilities. So these are all going to be 24 volt inputs and outputs. All right, you got the ground connections and things like that, and on the top. So we're going to go through more of the configuration of this after we've done this first introductory video. So lots of I/O, lots of options for this for expansion. As you can see here, we've got OPTO isolated, what looks like OPTO isolators. I'll verify that in a moment. Lots of protection logic for the inputs and outputs. I don't have schematics for this, so we're going to have to see if I can get a magnifying glass out and maybe have a look at what some of these parts are. But again, very, very well built. No bodge wires that I can see anywhere in sight, so it's a good level of board. On the back here, they've put a little bit of hot melt glue on a few things. And I think what that's for is to prevent it from catching and causing damage to this cable, because when it's in here, it's kind of coiled around. So if it was, these are all not surface mount, they're through hole connections. So one of the reasons for the cable being with the hot melt glue here is to probably protect the cable, because you've got all of these through hole soldered connections which would have sharp edges on them, and you wouldn't want it abrading the cable and maybe breaking through to the internal wiring, the internal metal of it, and shorting things out. So having the hot melt glue here just provides a little bit of extra protection. There isn't anything on the very edge ones, but then it's unlikely that the wires would catch on that because it's so close to the edge of the cases and everything. Anyway, so that's the last board that we have here. Again, you know, more configuration switches on here. This one looks like it's for the voltage reference for the ADD conversion, and selecting your supplies and things like that. But we'll have a look at the manual in a little bit just to see what that's for. And what else is on here? Yeah, another set of I/O indicator LEDs to tell you what's happening with things. So yeah, that's all the various pieces that we have to look at. As you can see, completely based on Arduino hardware and open source hardware, and of course because of that open source software. So it really, the use of this stuff is only even limited to your own imagination. And I'm not sure how easy it is going to be programming and setting this up, but we will find out very, very shortly. So just before we leave this, I'm just going to put my macro lens on the camera and see if we can get some close-up shots of some of these parts so that we can look them up, or you can look them up, so you know what they are. So let's go, just let me do that and we'll move on. So this is a close-up of one of the OPTO isolators that's used across all of the different boards. Looks like it may be a Fairchild D207 with a 141S on the second row there. I'm not sure if all the other ones have a similar marking, but let's just go look at one of the other ones on here. I can just bring it into focus. There we go. So that's the same, D207 141S, and that one was a D207 141S. So that's on the smaller of the boards, the PLC 20, so the Oddbox PLC 20. Now if I pick up the one that works with the MEGA 2560 and have a look at what the relays are on this one, we'll see if they're very different. We'll just let it try and focus on them. So that's a D207 115S. I don't know if there's any difference in that, whether it's a date code, D207 115S. D223. Yeah, these are all a little bit different, so I'm going to have to look up these, and I'll put in comments when I post the video what I can figure these out to be. Let's just try and focus on some of the other ones. D207 115S, D223. So ST Micro 9202, ST Micro 2902. Let's have a quick look what that is. So a 2902 is a low power quad operational amplifier. So probably part of, if you're using analog inputs or something like that for this, or potentially level shifting from 24 volts down and back up. Well, no, it's going to be used for the analog inputs, I'd imagine. Anyway, LM2902 is a quad low power op amp with a bandwidth of about 1.3 megahertz. Open loop gain 100 dB, low input bias current 20 nanoamps, and works on a single supply up to 30 volts or a split supply plus or minus 15. So that's what that is. And looks like they're driving into what are those marked as? See if we can see what they're marked as. Well, they're marked as used, but they look like they're diode. So they're probably diode protection on the inputs of all of those. They're all going directly to the connectors there. The op amps look like they're being connected directly to it. All of the interfacing on here seems to be the 2902 quad op amps. So they could be using those to boost the logic of the Arduino up to the 24 volt supply, or whatever supply you happen to be running this with. Well, actually it's 24 volts. The top, these are just all the individual red and green LEDs for status indication, bunch of resistors for it, and that's pretty much it. on there, so let's just get that out of the way. Let's look at the Ethernet main board. This is the board that the 2560 sits onto. So you can see this is the Ethernet board that uses the ENC28J60. I've used this numerous of times in the past with various Arduino projects, and it's a very capable little Ethernet controller. You rely on having a lot of the code in the Arduino controller itself. So having one of these with the Leonardo would take up most of the stack space that's available there, but having it on a 2560, of course, is not an issue because you've got plenty of space. What else do we have here? We have a Max 485, so that's an RS485 driver IC, which is great to see there. That allows us to get Modbus implementations up and running and things like that. There's two of them. There's another one underneath the ribbon cable there as well. Probably one for transmit, one for receive, or allowing us to have 3 channels of transmit receive, all at RS232 or RS485 levels. See if I can move this cable. Okay, pulled the cable out the way so we can have a look. So that's a Max 232. So those are for RS232s, and then we have a Max 485. So looks like 2 of the channels would support RS232 and 1 of the channels supports RS485, which is fine. That's all you really need on an industrial control solution anyway, because an RS485 is a daisy channelable bus, so you don't need to have separate ones for different devices. RS232 on the other hand is not the same, so that's why having the other 2 as that would be beneficial. So no complaints there. As I say, nothing else on this board looks of interest that we can see, so let's just move along. Going back to the Arduino Leonardo board, and there's another Max 485 chip on it. So again, you've got the full RS485 capability. Trying to see if there's anything else. Nope, they're all consistently using the 2902 from STMicro, which is the quad op amps, which means that looks like it's your output drivers, OPTO isolators, 2902s, a Max 2. Oh, there's a Max 232 as well. So the same thing here. We've got the option of RS232 as well as RS485, which is great. They're being consistent across all of their boards. There's the Omron relays. They're upside down there. Are they up the right way over here? Yeah. So you can see 5 volt DC, so 5 amps, 250 volt AC capable relays. I'll have to check the specifications because the wiring is not always done to fully support the relays, but they're a good brand. They're Omron, so that's really nice to see. 5 volts, so they're not, they're being driven directly from the 5 volt supply. Although there are some transistor drivers, so you're not, trying to drive this directly from the I/O of the Mega or the 328, which is good because it wouldn't be capable of it and be able to reliably do that. And a whole bunch of other passives and probably protection logic and things like that in here. That's looking at the input pins there that stack up to the microcontroller board. So yeah, lots of input protection, transistors, etc. So without any schematics, I'll just be guessing at how that's configured. I'm not going to. We'll just rely on the specifications. But basically, the board looks like it's very well made and should stand up very well in an industrial environment. So let's start assembling this thing back together. So we'll start off by reassembling the Arduino Leonardo based board, which is the Artbox PLC 20. So first thing to do is take the Leonardo board, tip it upside down, and drop it onto its pins, making sure they're all lined up. Now you can see there are these little standoffs that allow you to secure the boards together and give it some grip so that vibration is not going to pull them out or anything. So I'm just making sure that they're all plugged into the proper connections before I push it down, which they are. So I'll just put that on a solid surface, make sure the little pins are lining up, and push it home. So yes, that's all it took, a little bit of just a gentle wiggle just to get the plastic through the holes. It's a nice snug fit, and that's securely put the Arduino Leonardo back in its rightful place. Now we'll take the power supply module and this again tips upside down, and now you've got two 3-pin headers here and a 3-pin socket here that you've got to make connection with. So we'll just gently, and there's also 3 standoffs for this. Now these have been trimmed off a little bit, looks like, which might make it a bit harder to get it in here. Probably because it might have been touching the top of the case or something like that. So a little bit of a bodge there from a design perspective, but we'll see what we can do. So that just plugs in there. These tall standoffs. Oh, that one popped in okay. And that one, and we've got one more. Yeah, there we go. Not necessary, just takes a little bit of gentle but firm force to get it in. So all those connections are now nicely in place. And because of the standoffs and the tight securing of these, they're not going to be vibrating loose anytime soon. So now we've just got the lid for this to go on, and that you can see here they have little tabs that secure it, okay, on each of the sides. So you just flip that over, and if you do choose to take your own apart, you have to be very, very careful. When I did this one, I've got one of the tabs a little bit loose here because of, and I used very gentle pressure, but they really aren't designed for putting together and taking apart over time. So just be careful when you're doing it, if you do it, because you might break one of the tabs off. So just clip that into place. Make sure you put the relevant indicator, of course, there. That's not the one, but they put it. It's amazing how far those things bounce when you're not paying attention. So just got to make sure we put this in before we secure everything down. And clip in the last tab. And there we go. Oh, it just needs, of course, the yep. Don't forget to put the plastic little clip in before you tighten it down. Yeah. And there we go. One industrial shield. Now let's get the 2560, which is going to be a little more challenging because it's got more parts to it. But I guess the first thing to do will be to put the power supply back on here. So same as before. Oh, this one has trimmed a little bit tops too. Anyway, we'll drop this one in. Make sure we get all the connectors hooked up. There we go. Get the plastic standoffs lining up as well. And a little bit of gentle pressure, wiggle it a bit, and there we go. There's the power supply module all nice and securely hooked in. Now the back of this one, as you can see here, the main controller, this is already the back of the board on this one. So what we can do now is the this box, which is the empty case, is the one that goes on the back. Okay, which allows us to have our standard I/O here with our interrupt based inputs as well, various I/O on this side, and then of course our configuration switches and more I/O on this side. So that one just clips in, and the wiring, just make sure you got that on the right side. Of course you need your indicator as well plugged in to make sure you've got that correct. Yep. Okay, drop that in, line up all of our pins. And there we go, all clicked nice and tightly back together for that side. And there we go. So this is the other side, so we take the AT MEGA2560, but before we put that in, let's make sure we get the ribbon cable back in for the Ethernet. It's keyed, so even though it wouldn't make any difference technically which way around we put this, because it's got a key in it, it'll only actually go on one way. Okay, that's that done. Now we take the 2560. Sorry, that was the ribbon cable I was just plugging in. It's got a key on. So the 2560 goes upside down. Make sure it gets into all of its connections. So there's only 3 standoffs on this one. There isn't one on this side, probably because there was tracks in the way or something. But 3 should be more than enough to hold this. So we'll just push it down. Lots of connections to push in. So it's not going to go anywhere in a hurry. So make sure all of the connections are in, which they now are. So you've got your USB, you've got your Ethernet, you've got your power, your reset switch, your auto reset, probably like some kind of watchdog, and a couple of status LEDs. So now that we've got that done, we need to marry it up with the I/O board. Let me just zoom out a little bit for this shot. First of all, of course, we need to put the front bezel back on before we start hooking everything else in, otherwise it won't go in as nicely. So that just hooks in there. This cable needs to plug in here like so, and it has a key in it to make sure it doesn't come out properly. So make sure if you do this, make sure you push it well in. Now this is not probably going to allow me to have this cable here, because I'm thinking that the Arduino may have it. We'll just see. I can't remember whether it was on the inside of here. It might have been. So inside here. And it looks like it neatly actually lays around this box. So just clip the last panel into place and we'll be done. And there we go. And of course the last thing that needs to go in is the little DIN rail clip. It's got a little spring and it just goes into the DIN rail like so. Just make sure we've got all the pieces here. Just capture the spring underneath. Slide it into place. And there we go. So now we have our first module. I just quickly put the spring back on the smaller one. Same thing applies, just drop it down, slide it into place, and there we have it. So 2 industrial shields ready to go. And one of the things I mentioned before is the pull-ups for the I2C bus, if you're going to do it. So you can actually buy from Industrial Shield or the Boot and Work Corporation a couple of DIN rail mount pull-up resistors already mounted on a header, so you can just clip these on the DIN rail at the point where you want to terminate your I2C, or at least apply the pull-ups, which is usually at the end of the line, and just wire into them and you're done. Provide the plus volts, of course, and that will be it. So that ends the quick tour of the actual hardware for the Industrial Shields. I'm going to split the video out and make the view of the software one a separate video, because I know it's going to be a little more involved in the previous ones. And also I'm not as concerned because it's going to be Arduino Mega and Arduino Leonardo / Uno kind of programming that we're going to be doing to get this up and running. So we'll go to that in another video. That'll be pretty much it as the initial look. So I do actually quite like what I'm seeing so far, and I love the fact that these are all open source hardware with regard to the Arduino Leonardo and the Arduino MEGA2560.